So hello everyone, and good to see all of you for today's session. So if there is someone, is there someone over here who is joining for the first time? I see 7 students. So if someone is joining for the first time, could you please raise your hand or unmute yourself or write in the chat box? So Siddharth is joining here for the first time. Okay, so hi Siddharth. Since you're joining for the first time, I would just briefly tell you about what these sessions are for. So these sessions will be conducted by me. So I am one of the TAs for this course on Essential Mathematics for Machine Learning. And I'm Radhika and I'm pursuing my PhD in physics from IIT Kanpur. And before that, I did my MSc in physics from IIT Kanpur itself and my BSc in physics from Miranda House College in Delhi University. Now, in these sessions, we would be solving some of the previous year's assignment questions. And these previous year assignment questions would help you solve the current year's current week assignments questions. So most of them I've seen are kind of similar. So if you are able to solve the previous year's assignments, then you would be able to apply those concepts and solve the current year's assignment problems. And since you are new over here, I would like to share with you the links for this course. So I have put the link to the YouTube channel in the chat box. So please go there and make sure you subscribe. Then you will come to know the notification for every such problem solving sessions that we have. And you can go to the channel and see the problem solving sessions for the previous weeks as well, for the previous assignments that we have had. So every week we solve some questions from the previous year's assignments. And apart from that, I will share with you the Google Drive link. This Google Drive link is where you would find all these lecture notes that are there. So just give me a second and I will share with you this Google Drive link as well. So these are the two links that you should keep, you should save, bookmark them and keep in mind. So this Google Drive link is where the notes for the previous year's assignments are there. And for the previous weeks that we have solved. So just make sure you save this Google Drive and you subscribe to this YouTube channel. So I see Anushri has joined right now. So Anushri, are you joining for the first time today or have you been attending the sessions previously as well? Okay, I'm not sure if Anushri can hear me. Nevertheless, so we will start with today's session. Now, the problem that has come up with the scheduling of the course is that we started off with week 0. And then we had week 1 and week 2 assignments, both of them at the same deadline. So you had to submit assignment quiz 1, quiz 2, both on the same date. And then you have the quiz 3. So what has the problem that has come up with that kind of scheduling now is that you have quiz 3.
We can now, ma'am.
Okay. So yeah, I think there was some technical network glitch from my end. So that is fixed now. So yeah, so I was saying that because the schedule has gone a little bit off, we started with week 0, then week 1, week 2 assignment on the same date, and now week 3. So you would have to submit the week 3 quiz before we meet next Saturday. So what I am planning to do is I will start with assignment 3 of the previous years to discussing the assignment 3 first, so that you can attempt the quiz 3 properly. And quiz 2, you would have already submitted it. So we would discuss the quiz 2, the assignment 2, after we complete assignment 3, if time permits. And if time is not there, then what I will do is I have already prepared the notes for it. So I will upload the notes on the Google Drive link, and I will also create a video for you where I will solve it explaining all the steps, and I will put that video on the YouTube channel as well. So you will have that and you can use that to prepare for your mid-sem and end-sem exam. But today, first off, we will start with assignment 3. Hopefully, this will be more helpful in solving this week's assignment. So does that sound like a good plan? Or do you want me to start with assignment 2? So this is fine, right? Everyone is fine with this? Okay, great. So we will start with assignment 3, and if time is there, we will discuss assignment 2. So this is the first question for assignment 3 from previous year. It says that we have a 3 cross 3 matrix, a 3 cross 3 matrix with real entities, and then we are given that if we take the combination A transpose and name that as B, then B has eigenvalues 1 and 4, and the trace of B is given as 30. Then we are supposed to find out singular values of the matrix A. Now, by the property of trace, we have trace of a matrix is the sum of eigenvalues of that matrix. And this sum we are given is 30. So we are given that this trace is 30. And we are also given some of the eigenvalues 1 and 4. So what we have is 30 is equal to 1 plus 4 plus the unknown eigenvalue, which we shall call x. So this gives us what? X is equal to 25. So the unknown eigenvalue of B is 25, and singular values are nothing but square root of these eigenvalues. Square root of these eigenvalues of the matrix B equal to A transpose. So this gives us square root of 25, square root of 4, and square root of 1, which is nothing but 5 to 1. So option D is the correct answer over here. Next is this question over here on another matrix. So we are given a 2 cross 2 square matrix, and we are given the singular values, the two singular values for this matrix. And then we are told that if this is the corresponding singular value decomposition, and we are given what this matrix V is, and we need to find out the matrix U. So now in the singular value decomposition, the columns of the matrix U, which are denoted by Ui over here, are given as follows. So here Vi is the ith column of the matrix V, and sigma I is the ith singular value. This combination will give us the ith column of the matrix U. So that's that, and then we will we can put these values over from here, and then we will get, let's say we'll start with U1. So U1 is A V1 over sigma 1. So before starting this, I would like to tell you that this is just a trick to use for solving MCQ problems. You see that the second column is different for each of this matrix. So to save your time, it makes more sense to start by finding out the second column, that is U2. But just for the sake of completeness, I will start with U1 and show you the process, and then we will go to U2. But this is just like one trick you can use to solve the questions in less amount of time. For example, in your mid-sem and end-sem exams, you can basically try and identify which particular thing you should first solve first in order to get the answer faster. So anyway, we will start with the first column. So sigma 1 is given as square root of 32. So square root of 32. A is the matrix given. And then the first column of V1. So this column. This is 1 over root 2 and 1 over root 2. So we will take this 1 over root 2 common and club it with 1 over root 32. That will give us 1 over root 64, which is nothing but 1 over 8. and then we have these. So this gives us, just multiplying, this gives us 8 and 0. So this is 1, 0. So it has to be either A or B. Then we will find out the second column. So similarly for the second column, we have like this. Now the second singular value is 1 over root 18. So 1 over root 18. Then the matrix A. And now the second column. So this one right here. 1 over root 2, negative 1 over root 2. Again, we will take this 1 over root 2 factor common and take it out and combine it with this 1 over root 18. This whole thing will then give us 1 over 6. And then the matrix. So solving this, just multiplying 0, negative 6, which is nothing but 0 and negative 1. So that means our matrix U is formed by these U1 and U2 columns, which is as follows. So this is option number B in our case. Now we have another question on singular values. So what this question says is that if the singular value decomposition of a matrix, this is a 5 cross 7 real matrix, and the singular value decomposition is like this, U sigma V transpose, and we are given the rank of the matrix A, and we need to figure out which of these statements is supposed to be true. So if we look at is not true, sorry, which of the statements is not true. So if we look at the first option, then we are given that rank of A is equal to 4. Now, from this, we know the property of range and rank, how they are related. So this was discussed in one of the lectures in week 3. I think lecture 2 or 3 maybe. So this is first R columns of U is the range of A. Now R is 4, so this should be first 4 columns of U. So clearly this statement is wrong. But we will look at the other statements also, and just for your knowledge, I will write down all the properties that was discussed in the lecture so that you can revise it. So if we have a matrix A, which is an M cross N real matrix, and let the rank of this matrix be R, and suppose it has a singular value decomposition like this. This is the singular value decomposition. Now, the properties that we have is that first property is R is the number of non-zero singular values of A. Then next property is on range of A. So range of A is given by the first R columns of U. Then next is on null space. So null space of A is given by, sorry, not first, this time it is last n minus R columns of V. Then we have for the transpose, A transpose, same properties, range and null space, but for A transpose, this time it is first R columns of V and null space of A transpose is last m minus r columns of U. So these are the properties that we have. Now, in our case, we have m equal to 5, n equal to 7, and r equal to 4. So you can see that statement B is true because null space of A is last n minus r columns of V. So n is 7, r is 4, 7 minus 4, that is 3 columns of V. This is true. Similarly, range of A transpose. So range of A transpose is first r columns of V. So first 4 columns of V. This is true. And the null space of A transpose is m minus r columns of U. So m is 5, r is 4, 5 minus 4, which is 1. So this solves the third question. Next, moving on. So here is another true false type question. So we are given a matrix B and we need to find out which of the following is supposed to be true. Now these are the different norms that are given. So let me write down the definition of all the norms that we have. So if we have A being an m cross n real matrix, then we have the different kind of norms. So let me define the matrix P norm. And for P equal to 1, we have as follows. So this is the first norm. Then we have P equal to 2 norm. This is given by the maximum singular value of the matrix. Then we have the infinity norm. So notice that the P equal to 1 and P equal to infinity norms have similar definitions, just the row summation and column summation are interchanged. So here we are summing up over I. So we are keeping J fixed and summing up over I. So we are summing up all the elements along one column. And in the infinity norm, we are keeping the I fixed and summing up all the J values. So we are summing up along the row. So this is this, and we have the next Frobenius norm. So Frobenius norm is given as follows. It is formed by summing up the singular values, the square of the singular values. And this is equivalent to saying the following. Because the sigma I squared are basically the eigenvalues of this A transpose A matrix, and sum of eigenvalues is the same as trace. And there's another definition for Frobenius norm. You could use whichever you find convenient. So all these definitions are equivalent. Now let us look at our given question and try and find out the norms. So for our case, we have m equal to, sorry, we have m equal to n equal to 2. This is our case. And then let's find out the p equal to 1 norm. This would be, given our matrix, we are keeping j fixed and summing up over I. So this is first element 2, then next is 0, summing up column wise. Then the next column, that is mod of -1 plus mod of 2. So this is max of 2 comma 3, which is equal to 3. Again, from the point of view of solving the MCQs, we see that the first norm is 3 for all of the cases. So instead of solving for the first norm to save our time, we can start with the second, the infinity and the Frobenius norms. But just for the sake of understanding and solving all the parts. Next, let us look at the p equal to 2 norm. So for that, we need to form the matrix B transpose B in order to find out the singular value. So B transpose B, this is B transpose, and this is B. This multiplying gives me the following. And now, eigenvalues of B transpose B we need to find out. So this is B transpose B minus lambda I. So that means 4 minus lambda, -2, and here 5 minus lambda. This is for finding the eigenvalues. So solving this, we can use a calculator to solve this. The answer comes out in some decimals. So the solution to this problem is as follows. So these are the eigenvalues. Now sigma 1 is square root of the largest eigenvalue. The largest eigenvalue is 6.56 over here. So square root of 6.56, this is 2.56. So that means the second norm is 2.56. So we can see, so we have already solved the question. Second norm is 2.56, so it should be option number B. But we will look at the Frobenius and infinity norms as well. So next, let us find out the Frobenius norm. Yeah, Frobenius norm. Frobenius norm is nothing but trace of this B transpose B that we just found out and square root of that. So we see this is B transpose B. Trace is sum of diagonal elements. So that is 4 plus 5. Square root of 9 is 3. This is the Frobenius norm. And then the infinity norm. So this is the definition for infinity norm. Infinity norm is when you keep I fixed and sum up along the j. So that means you sum up along row. So summing up along row, this is mod of 2 plus mod of -1. And next row is 0 plus 2. So mod of 0 plus mod of 2. This is again max of 3 comma 2, which is equal to 3. So we have found out all these norms and we have solved this question. Next is question number 5. So this is another question on singular values. So we are given that if the singular values arranged in descending order, so singular values are typically arranged in descending order. So if the singular values arranged in descending order of a 4 cross 4 matrix are 3, alpha, 1.5 and 1, and the measure of quality of the rank 2 approximation of A is 0.8. So this 4 cross 4 matrix is A. So this is A. Then the value of alpha is, so we need to find out this value of alpha in the singular values that we have. Now it's a 4 cross 4 matrix and it has 4 singular values and they are arranged in descending order. Now even so, the way this question has been designed, I do not like the way of this question has been framed, because even without solving this question, you can get that the answer should be 2. Why? Because it is arranged in descending order, and so it should be less than 3 and greater than 1.5. So the only option which is less than 3 and greater than 1.5 is option C, that is 2. But we will solve the question for you so that you know what quality means. So measure of quality is defined as follows. So you have, so when it is a rank 2 approximation, so that means you select only the 2 largest singular values. That means you select 3 and you select alpha. So only these 2 singular values you consider for a rank 2 approximation. Had it been rank 3 approximation, then what all you would have considered? You would have considered 3, alpha and 1.5. So now quality of measure of the low rank approximation is given as sum of squares of the singular values. So 3 squared plus alpha squared, sum of squares of the singular values used in that low rank approximation. So since we are using only these 2 singular values in the rank 2 approximation, so it is 3 squared plus alpha squared divided by sum of squares of all the singular values in the original. So original had these 4 singular values, so sum of squares of all of these. And this we are told is equal to 0.8. So let us solve it to get the value of alpha. So 0.8, numerator is 9 plus alpha squared, denominator is 12.25 plus alpha squared. So let us simplify it. And rearranging some terms. So this gives us the following. And from here we will find out that alpha squared is equal to 4. So alpha is indeed equal to 2, as we had guessed earlier. So moving on. Now we need to find out the rank of this matrix. So rank of a matrix by definition is the number of non-zero rows in the reduced row echelon form for that matrix. So we need to apply row operations and do row reduction on this matrix in order to find out the rank. So let us apply those row operations. So first we will do R2 goes to R2 by 2. This gives us the following. Then we will go R2 goes to R2 minus R1. So R2 is R2 minus R1. So we'll get this. Now the next operation is R3 goes to R3 minus 4R1. So now R3 goes to R3 minus 4R1. So this becomes 0. So like so. Then what else? So next operation would be, let us say R3 goes to R3 minus 3R2. Okay. So this makes it, this entire row equal to 0. And just we will do a few more operations just to tidy things up. And so that strictly speaking, it becomes into the reduced row echelon form. So we do R1 is R1 plus R2. This makes this element right here 0. And finally, we will make this element 1 by multiplying -1. So R2 goes to -1 times R2. So we see that only the last row is 0. So we have two non-zero rows out here. So this is the reduced row echelon form. So we have two non-zero rows. So the rank is equal to 2. Now moving forward, this question is, which of the following matrices is not diagonalizable? Now, diagonalization, let me just write down what diagonalization is. So, a matrix A can be written as follows, and from here we get this. Now, over here, what we have is B is a diagonal matrix. And the elements of this diagonal matrix are the eigenvalues of the matrix A. And P is a matrix formed by the eigenvectors of A taken as columns. And this would be in the same order as the eigenvalues. So in the same order that you write the eigenvalues, you would write down the eigenvectors to form the columns of the matrix P. And for a matrix to be diagonalizable, this P matrix needs to have an inverse because it is P inverse AP. And for a matrix to have inverse, the columns should be linearly independent. That means we need linearly independent eigenvectors for the existence of P inverse. Okay, so for P inverse to exist, the columns need to be linearly independent, and for that we should have linearly independent eigenvectors. So now let us look at the options that we have. Now we see that this is an upper triangular matrix because you see that only these elements are non-zero, or rather you see that the elements in the bottom triangle are 0. So all these elements are 0. So it is an upper triangular matrix. Now in upper triangular matrix, what we have is, so upper triangular matrix, the eigenvalues are diagonal elements. So if we see the diagonal elements, we see that the eigenvalues for this case would be 1, -1, and 7. These are the diagonal elements, and for upper triangular matrix, you can directly say what the eigenvalues are by looking at the diagonal elements. So these are distinct eigenvalues. And the property for distinct eigenvalues is that distinct eigenvalues always give linearly independent eigenvectors. So if you have linearly independent eigenvectors, 3 linearly independent eigenvectors, then you can form the matrix P and you can find out the inverse of P. So this matrix is definitely diagonalizable. Now let us look at the matrix B. This B also you see is an upper triangular matrix because this is 0. Yeah, indeed, we have these elements also as 0. But the main aspect is that this bottom triangle is 0. So if the bottom triangle is 0, then it is an upper triangular matrix. And once again, for upper triangular matrix, we have the eigenvalues as the diagonal elements. So this is again an upper triangular matrix. And the eigenvalues for this would be the diagonal elements, which is 1, 2, and 3. And again, we see we have distinct eigenvalues. So distinct eigenvalues would always give you linearly independent eigenvectors. So once again, you have 3 linearly independent eigenvectors corresponding to these eigenvalues. So you can form the matrix P, which would be invertible. So option B is a matrix which is definitely diagonalizable. Now let us look at option C. So this is not an upper triangular matrix, so we need to find out the eigenvalues the conventional way. So eigenvalues in this case would be, we will find out the determinant of the following. So this determinant solution to this would give us the eigenvalues. So let me just find out the determinant. So this is just expanding along the first row to find out the determinant. And then just simplifying the expressions. Now we can take 4 minus lambda term common. And that would leave us with the following term. Again, we just want to simplify and factorize everything. and so this 2 gets cancelled. So lambda square minus 3 lambda is left. This gives the following. So the solution to this characteristic equation is as follows. So we have eigenvalues as follows. Zero, 3, and 4. So lambda equal to 0 from here, lambda equal to 3 from here, lambda equal to 4 from here. So again, we see that we have distinct eigenvalues. So distinct eigenvalues, and this will give linearly independent eigenvectors. So we have linearly independent eigenvectors, 3 such eigenvectors, and we can form the matrix P, we can invert the matrix P. So this option C is definitely diagonalizable. So that leaves us with option D, and that should be non-diagonalizable, and we will check whether that is true or not. So right now, since A, B, C are diagonalizable, we can say that D is not diagonalizable, but we should check it for ourselves. So we will check it over here. So let us find out the eigenvalues. So eigenvalues would be the determinant equal to 0 of the following. So this gives us 0 is equal to negative lambda cube, which implies lambda equal to 0 and repeated thrice. So this has a multiplicity of 5, degeneracy of 5, or algebraic multiplicity of 5 of 3, sorry. So degeneracy, or you can call it algebraic multiplicity, and this is equal to 3 because it is repeated thrice. So same value but repeated thrice. So now we need to find out whether we get 3 linearly independent eigenvectors corresponding to this eigenvalue or not. So let us find out the eigenvectors. So this is the solution, this is the equation corresponding to the eigenvectors, and x is the eigenvector. So let us consider the components like so, and we can represent this in the augmented matrix form as follows. So we will have the augmented matrix form where we write the matrix A and we write the right hand side. So we write not just A, sorry, we write this matrix A minus lambda I and this 0, the constant. So this is the augmented matrix form, and we need to find out the value for x or these components. So from here, we see that the equations, so if you look at the first equation, let me consider the first equation over here. Let's say this first equation. So this first equation would give me 0x1 plus 1 times x2 plus 0x3 is equal to 0. This gives me x2 is equal to 0. Next, if we look at the second equation, this one, this gives me 0x1 plus 0x2 plus 1x3 is equal to 0, which implies x3 equal to 0. So we have x2 equal to 0, x3 equal to 0, and x1 can be anything. So for so the eigenvector that we have is x1, 0, 0. So, and for normalized case, we will consider this to be 1, 0, 0. So we see that we have only one linearly independent eigenvector. So if we change the value of x1 from 1 to 2, 3, 4 or -1, those would be just the scalar multiples of this eigenvector 1, 0, 0. So they will be linearly dependent. So in this case, we have only one linearly independent eigenvector, just one. So that means we cannot form the matrix P. Why? Because it's a 3 cross 3 matrix that we have. So P needs to be 3 cross 3. And if we have just one column, we can't really form the second and third columns. So we cannot form P. And since we cannot form P, or P inverse cannot be found, so that means that this matrix is not diagonalizable. So option D that we had selected is indeed correct. So moving forward, we have question number 8. So this is a 2 cross 2 matrix with real entities, and these are the eigenvectors of the 2 cross 2 matrix that we are given, and the eigenvalues also we are given. So then we need to find out the matrix A. Now I had just written down this diagonalization for you over here, this expression right here. So we will use that to find out the matrix A. So we have A is P, D, P inverse, and P is what? The matrix formed by the eigenvectors. So eigenvector is 1, 2, and the eigenvectors should be written down as columns. So 1, 2, and then 2, -1. So this is the thing. So this is the matrix P, and matrix D is what? It's a diagonal matrix. So off diagonal terms are 0, and diagonal matrix with the diagonal elements as the eigenvalues written in the same order as you had used for writing P. So the first eigenvector in P corresponds to the eigenvalue of 4. So this is the first column, and this corresponds to eigenvalue 4. So we will have 4 over here. Then we have the second column of P. This corresponds to eigenvalue value 9. So we will have 9 over here. So this is the matrix D. And from P, we can find out the P inverse. Now for a 2 cross sessions timings were overlapped. Okay, wait, someone is saying something in the chat. This session's timings were overlapped with the theory of computation class offered by IITK. So it's a request that from next session, kindly choose different timings. Thank you. So Shashi, we will discuss upon this after this class as to what to do about this. So yeah, we will discuss after. Only few questions are left, and we will surely discuss upon this. So coming back to this question, so we have a P inverse we can find out. Now for a 2 cross 2 matrix, it is a very simple to find out the inverse. You can use a simple trick. What is that trick? That you do 1 over determinant of P. So determinant is -1 minus 4. So that's -5. And then what you do is you swap the diagonal elements. So the diagonal elements get swapped like this, and you multiply -1 to the off diagonal elements. So like this. You can use this simple trick to find out the inverse. Otherwise, you can find out inverse of bigger matrices by the standard formula. 1 over determinant of the matrix times adjoint of this thing. So you can use this basically. So this is like the general thing to find out the inverse of a matrix. But for 2 cross 2, any 2 cross 2 matrix, it becomes very easy. So you have the determinant of A determinant is in our case simply negative of 5. So 1 over minus 5. And then this is essentially the adjoint. So if you use the proper technique of finding the adjoint of A is nothing but transpose of cofactor. So you have the cofactor matrix and it's the transpose of the cofactor matrix. But for 2 cross 2, we have a simpler trick to find out the inverse. So now we have P inverse, we have D. So we can basically solve this by multiplying. So A is P, D, P inverse. So this is P and this is D and P inverse. So this is 1 over negative 5. Let's multiply negative sign inside the matrix. So we have 1 over 5, 1, 2, 2 and negative 1. So this is the thing. So let us just multiply and simplify. So this is multiplying the first two matrices and then the last one written as it is. Then now we will multiply these two. And now dividing the whole thing by 5 gives us the following. So the correct option is option C, 8, negative 2, negative 2, 5. The last two questions are very simple. It is based on the Python implementation. So you can see week 3, lesson 3 for these. Sorry, week 3, lesson 5. Week 3, lecture 5. You have the Python implementation. So the first question says, in this Python thing, the Python library NumPy is used for which of the following tasks? A, creating graphs, B, working with arrays, C, developing machine learning estimators, and D, for arithmetic operations. The correct answer is working with arrays. Then the last question says, in Python, which of the following function performs singular value decomposition? So singular value decomposition is performed by this option B, which is numpy.linalg.svd. So linalg thing basically stands for linear algebra, and this this package basically you would use for all kinds of linear algebra based problems. For example, in the previous weeks you would have seen numpy.linalg.eig for finding out the eigenvalues and the eigenvectors. So this solves the week 3, the assignment 3 for previous year's questions, and you can basically use these concepts now to solve the current week's assignment 3, and hopefully it will be helpful to all of you. And I see that we are not left with much time. Like, even though I tried to be as fast as possible, I see that we are not left with much time in this session. So what I will do is I will upload the notes of assignment 2. So I have already done assignment 2. I've written down the questions. I already have worked out the solutions also. So I will upload the worked out. So this was prepared to basically work out in the live session. But this assignment 2 is there. 10 questions are there here based on linear transformations, norm of matrices, and orthogonal projection is there. Some questions on orthogonal projections are there. And this is another question on some orthogonal matrix, and something on quadratic form, and something on the positive semi-definite matrix. So these are some questions in assignment 2. What I will do is I will upload the solutions to this in the Google Drive, And if possible, if you people want it, like even after the solutions, if you people want, I could create a YouTube video explaining the steps for you, and then you can have a look at that YouTube video. So this was all from my side for today's session. I wanted to start with assignment 3 so that you can work out the current week's problems. And as Prabhu had pointed out earlier, that I had forgotten to upload the previous week's slides. So the video is there on the YouTube channel, but the slides I had forgotten to upload. So I will upload all of these things, the assignment 1, assignment 2, and assignment 3. All these slides on on the Google Drive link for you. And yeah, that's all from my side. So those of you who joined a little bit late and who are new, here is the YouTube link of the channel. So please go there and subscribe to that channel. And the Google Drive link where I will upload these notes are here. So these are the links. People can save them. Now, Shashi was making a point about some clash of timings. Shashi, do you mind unmuting yourself and explaining to me exactly what is happening? Hi, Shashi. I see that your camera is on. Could you please unmute yourself, Shashi?
Yeah. Actually, there is a live session. There is a live session for theory of automata, and the
Theory of
timings were
what?
clashing. There is a session, a live session for the theory of computation class.
Okay.
And both the timings were exactly same. I mean, 3 to 4.
Okay.
So it's a request that from future onwards, I mean, if you can, separate timings for both the classes.
So this theory of computation is where, like, is it on the NPTEL portal itself?
Yeah. Yeah.
So it is a course being offered by IIT-K, you are saying, is that right?
Yeah.
So yeah, it's good to know that people are looking at IIT-K lectures, because I am also from IIT Kanpur. So who is the professor who is offering this course?
Professor Raghunath Tiwari.
Okay, and the live session is being taken by some student of his or some TA, is that the thing?
Yeah.
So who is the TA, like, if you know the name?
Actually, I don't remember his name. Actually.
So because see, the thing is that these live sessions.
Is there any centralized, check so that
Yeah, so I'm
between
telling you what these live sessions are supposed to be in the back end, like for the administrators, what this live session means. So these live sessions are being taken by a few students, a few PhD students like me, who are being offered what is known as the Prime Minister's Research Fellowship. So we are PMR fellows, and we are supposed to offer live sessions as part of our teaching requirements. And NPTEL is the platform which is giving us this thing. So now each student is supposed to take these 1 hour live sessions every week, and for different courses. So each PMRF student is allotted some course, and then they are basically given some time slot. So the PMRF committee, the overall central committee, is the central thing wherein all the students are registered over there, and basically that central thing is there. So if you can tell me the name of the student, then I can basically find out his contact details from the central PMRF committee, the central website that we have, and maybe we can get in touch. So I can get in touch with him and try to see what is happening over there. So when did this course start, by the way?
Actually, the session is same. I mean, July session. The course is ongoing.
July session.
It's a 8-week course.
Okay.
And
it's an 8-week course. Okay. So, is there anyone else over here who is taking that course by any chance? Yes, no. Could you please type in the chat box? So Prabhu says no. If people can just mention whether they are taking the same course or if they are having some issue with the time clash or not. So it seems most of the people are not taking that course. So what I will do, Shashi, is that I will put up a query in the discussion forum, and
Okay.
people can respond to that query maybe. And if majority of the people are saying that it is causing a clash or something, then maybe we can get in touch with the NPTEL and the PMRF committee and try to work out something. But I would not like to give you any false hopes, because what we had been categorically told in the very beginning before the session started, that these timings are frozen like forever unless and until something extremely untoward is happening. So even if I fall sick little bit, these timings will not change. So even if tomorrow I have fever, let's say next Saturday if I have fever, I still have to take the class at the same time, because of this automated thing that they have. So they send automated reminders, so they need to basically change everything in their database all over again to any rescheduling to happen. So
Okay.
it's a little bit rigid, but I will try from my side. If you could just tell me the name of the student, maybe I can contact him on a personal note, and then we can try and figure out if something can work out. Yeah,
Okay. Okay.
Prabhu says
I mean,
that you can
I
anyway
don't
watch the
remember. I
YouTube
don't
thing.
remember his name because it's my first session there.
Okay.
But I will check his name and then I will post in the forum so
Yeah,
that
so
you can.
Prabhu has made a very good point that you could anyway watch it on the YouTube, but I will try the best that I can do from my side in trying to get in touch with that TA for that course. But again, I would not like to confirm anything. And given how the things and how the things in the administration are and how everything is a little bit rigid, I have very little hopes of something change
Yeah, I do understand the
happening over
constraint
here.
you have.
Yeah, but I will still, since you have mentioned it, I will still try from my side in trying to uh, basically see if something can work out.
Okay. Thank you. Thank you very much.
Yeah, okay. So thank you everyone. So I have the assignment 2 solutions also worked out. So before these sessions, I work out the assignment problems solutions, and then I solve them live in the session. So this is the assignment 2 solutions that I've worked out. So I will upload, I think, directly these solutions onto the Google Drive. And if you people want, you could put in the discussion forum that if you people want, then I will make a YouTube video also and put it up. But because the schedule has gone a little bit here and there because of week 0 and week 1 and week 2 quiz being on the same date, because of that reason I started with assignment 3 today, so that assignment 3 is due next week. So you can solve assignment 3 quiz 3, and yeah, hopefully you will be able to solve it now. Yeah, okay. Thank you everyone. Yes, for those of you who do not have the links, I'm posting the links again. You could just save it for yourself. So that's the YouTube link, and that's the Google Drive link. You can take it. Okay, then all the best for your quiz 3. And I am looking at some of the discussion forum questions also. I remember yesterday I was trying to answer some of the questions. One of them was by Jatin. He was asking something about some rank or something. So yeah, so if you post the questions on the discussion forum as well, I along with other TAs, there are other TAs also for the course. So we regularly check the discussion forum and try to answer as many questions as possible. So okay then, see you.
Okay. Bye.
Recording stopped.